Welcome everyone. Hope you're well. Hope you have a good day. My name is Paul Adelino. I'm a senior manager in the developer relations team at Vonage, and together with my colleague Sina, we're going to take you through a journey of how we got to have internet in our pockets and kind of what the future holds for us, and more importantly, how we're going to use that technology going forward. So I usually set up titles for my talks in a kind of more interesting way. So the official title is Introduction to Mobile Network APIs. I think a more appropriate title would be This API Revolution is Wireless, and we'll see why in a second. Okay, so in case you haven't heard of Vonage, we've been part of your community for quite a while now. But if this is the first time you're hearing about Vonage, we are a developer-friendly platform that enables everyone to effortlessly integrate messaging, voice, video, and lately network capability, the topic of today, into your application. So wherever you're building a chat application, a customer support system, an IoT network, we can provide those building blocks through a modern RESTful API, extensive documentation, SDK, sample apps, and everything in between. Specifically, myself and Sina are working in the tooling team, and we are responsible, among other things, for the tools we make available to developers. So this range from client SDKs to server SDKs to framework libraries to web components through a kind of UI. And lately, on the top right, you can see the SDKs that we launched specifically for network APIs. So before I go any further, let's just kind of do a bit of audience participation program. How many of you heard of the CAMARA project? So if you heard of it, maybe type like 1 in chat and 0 if you didn't. It'll be interesting to kind of understand if this is the first time you heard. Okay. Well, you're in the right place. This is the new set of APIs that we introduced recently. But to get to that, we need to talk of why we're getting there. So it's safe to say that every single one of you has a smartphone in your pocket, sometimes more than one. But without a shadow of a doubt, every single person has some sort of smart device that can connect to the internet and can have apps and so on. And these are the top 2 for 2024. You probably recognize the usual suspects. And moreover, the smartphone is by far the most popular way to access the internet. With more than 93%. And it kind of covers pretty much the whole population of the world. So you have 4.3 billion people using mobile to access the internet. But what's more importantly is the connectivity actually increased. So over time, you have more people having access to it, but also in different generations of that connection. So we traditionally know about 3G and 4G. The latest one is 5G. It's very much work in progress. It's in full swing at the moment, and the trend is going to go upwards for the next couple of years as network operators are adopting more technology, installing new towers, and so on. And there are new novel ways for internet to be accessed, like the Starlink. This is completely separate from the topic of today, but I've added here for completeness because this will be more and more a way to access the internet, particularly in areas where mobile operators, what we call them traditional mobile operators, don't have coverage or have very poor coverage. So going back to the magical handsets that we have in our pocket, you might wonder what are those specs that you see? Like this is the wrap sheet of an iPhone 16 Pro. It's pretty impressive. It has a lot of numbers. They're fairly unknown for people that don't work necessarily in the telecom industry. So it's sometimes confusing, and people usually look at it has 5G. That's kind of a topic at the moment. So in this case, it has. The same thing for Pixel 9 Pro, which is the flagship phone from Google for the Android platform. So to understand those numbers, I'm going to take you through a bit of a journey down the memory lane. And I'm going to skip kind of the invention of electricity because obviously it's outside the scope. So we're going to go straight to the 1900s and the invention of the wireless technology. So there are a couple of people in there that we can mention, and particularly if you did physics as a degree, like I did, you recognize the names. You might recognize Hertz as a name because that's how we measure frequency. You might recognize Marconi because he was quite a major pioneer in wireless telegraphy, and he even got a Nobel Prize in physics for it. But this was the early 1900s. with the advent of that, radio became very popular. So the 20s and 30s were a good time to get a radio. That was a one-way communication. It was using traditional radio waves like we have now. It was analog, so the AM scale that we have now over radios. It had low bandwidth, it had high interference, and it requires kind of large antennas to transmit over long distances. And that's why, you might, some of you might remember from old buildings, they had some huge, huge antennas. Things progressed a bit in the 40s and 50s when engineers discovered a new way to actually send signals using microwaves. And they call microwaves because the wavelength is just kind of from 1 meter to about 1 millimeter. So they could carry more information. It has a higher frequency. It had less interference from atmospheric conditions, and it could travel longer distances because of that. And obviously, you can see where this is going. Then, we have a stellar revolution. So everything became smaller and it became a two-way communication. So in the late 70s and 80s, we have what we call the 1G network. These are the very early networks. They were analog networks, not digital. So keep that in mind. And they have very limited coverage, they have poor call quality, and usually we had a lot of interference from other devices. And I must add a disclaimer here, all this slides from here onwards, about 5 or 6, are generated by AI, but what's interesting is generated by AI about a year ago. So you might see some weird things, but I like them because it adds a bit of of color to it. So if you look, for example, closer to those buttons, they have some weird characters because AI about a year ago couldn't do text very, very nicely. Later on, we had the 2G revolution. So this was the introduction of digital. The networks changed to digital. That meant the voice quality was improved, coverage was bigger, but also it had SMS. Right, so this is the first time where you could send a text message. It still had, problems, and if this is the Nokia 3310, which was a poster child of those times. So you still, if you remember back in the day, you still had interference, and if you receive a phone call, your TV might make some funny noises and so on. So yeah, it was a good thing, but this was the advent of SMS. So the SMS came up. You had data transfers. It was very slow. It was 64K. So this was compared to the modems back in the day. And by the early 2000, we progressed to the third generation, so the 3G, and this was introduced mainly for data transmission. So you have a faster data transmissions up to 2 megabits per second. You have better coverage and you have better call quality. They were done initially for voice and SMS, but as the data become more available, I think, and with kind of introduction of iPhone and some of Android phones, it became the sweet spot where the data consumption just took over. And it was the perfect storm, and the rest of history, as we say. So we have a shift here towards more kind of mobile internet usage, more data-centric services, and kind of laid the foundation for the 4G network that arrived in the late 2000s, early 2010s. And that was mainly for data. So data was the main driver for 4G. We achieved up to 100 megabits per second transmission. Everyone wanted data. The rollout was really fast because of that. It was a huge demand. People were happy to pay for it. There were mobile handsets that could connect. We're talking all Androids and iOS, and everything was really, really going kind of towards that. And obviously, we go to the 5G. There's a joke there with faster connectivity because everyone wants everything faster these days. The 5G concentrated more on data speeds, low latency, but also connecting a lot of devices together. So just to put everything together, I won't take you through all of this, but that's kind of a summary. The 2G was the digital, 4G was the data was important, and 5G is the current one. So now maybe this will make more sense. Now we're talking about this. So you might ask, okay, so where do we go next from here? Well, I'm glad you asked. That's why we're here. So I've asked you initially if you heard about the CAMARA project. CAMARA is part of the Linux Foundation, and it's a telco alliance to make available APIs that are embedded in the network. So it turns out that 4G and 5G networks have capability that's programmable. And it's not exposed for various reasons, mainly because there's a fragmentation in the market. So as a developer, you would have to use different providers, and you'll have to do that aggregation. That's what the Linux Foundation is kind of the CAMARA project within the Linux Foundation is trying to achieve. And by September last year, it achieved a funding model. What that meant is you now have 250 companies that come together and fund the development in the open of this particular standards for network connectivity. So we are part of that. Ericsson, our parent company, is part of that. They bought us a couple of years ago, and we are a big part of that. The project, because it's funded, it has a lot of governance around it. So it has a governing board, it has a steering committee, it has an end user council, and it makes collaboration much easier on a broader scale. And everything is done in the open. So they aim to provide all the necessary resources. So all those tools and services and APIs should be available to everyone, no matter where they are, so they can tap into that goodness that you have in the networks. So actually, we are part of a technical steering committee. One of our colleagues, Chris Howell, is an active maintainer in there. So for every working group, you have repositories, and the CAMARA project is actually a GitHub org. So everything is open source. All the repositories are public by default. If you want to go to github.com/CAMARA project, you'll find all the information. And they recently we did this entry page, and it has all the information in there. So you might wonder what sort of APIs you can access. The APIs are listed on that main page, and they're listed in the order of their life cycle. So you have stable APIs at the top. Those are the APIs that have a version 1, that are complete in definition, that we expect that to be stable for a while. And those are the APIs that we started making available to developers at Vonage as well. So far, we have SIM-swap and number verification as 2 APIs that we have available. And that's kind of a topic we're going to talk about today. So for every API, you have a project in there. So this is SIM-swap. The way it is structured is kind of similar. So you'll see the a kind of familiar structure folders when you move from one product to the other. So SIM-swap, for example, it's in the SIM-swap project. And the definition, the Open API spec definition, is under the code API definitions folder. It's an YAML file. It's something that people use. We have Open API specs for all of our products that we do at Vonage. In fact, some of you might have used it, but that's the standard, and that's what CAMARA project is using as well. So let's talk about SIM-swap. So SIM-swap is an API that allows you as a developer to add an extra layer of security to your apps. And what a SIM-swap means, it means that a number got ported from one SIM to another. So in effect, it shows a major operation with that phone number that might trigger some extra checks from you. A good example is if you have, for example, a high target for fraudsters in a financial sector, you might use that particular phone number as a 2FA. But if you see that phone number got ported, maybe it's a takeover attempt, some social engineering in the network. So at that point, maybe you'll want to add additional security to it. That's a very practical use case. The way it works, the API underneath is fairly complicated. It uses OpenID. It does a lot of internal things for security reasons. And this is what we call a backend authentication, is a process that happens on the backend. We will see another API later called number verification that does authentication of a device because it requires the device. And Sina is going to talk to us about that in a second. So to make an API request for SIM-swap, all you do is just send an API call with a phone number, and you add an age in hours, and it'll tell you if that particular number got moved to a new SIM within that amount of hours. The number of hours, it's purely up to you. It's from 0 to 2,400 hours, so that's 100 days. So within that period, you can test if it's If it's swapped, probably it's quite important. For example, if it's been swapped in the last 3 days, for example, maybe that's more important for you to add more layers of security when it's been swapped 90 days. Or you can do all sorts of business logic on top of that, as you see fit. So that was my part of the presentation so far. I'm going to pass it on to Sina. He's going to do a demo of a SIM swap and then tell you about number verification. So I am going to stop sharing my screen, and Sina is going to take over.
Yeah, thank you, Paul. So I will just do is my screen sharing? Okay, I'll assume my screen share is working. So yeah, so as Paul mentioned, SIM-swap is one of the network APIs, and using it like in the raw API, because it uses OAuth 2, can be quite complex because you have to do all of these things. Now, of course, we offer SDKs to make that simpler. So I have a little demo app here that I can show you, a Java SDK. And if I go to SIM-swap, what you need is, of course, the number. And actually, the SIM-swap API has two endpoints. It has one for checking the age, and another for giving you the last time it was swapped. So you give it the number, and then it will tell you the timestamp when it was last changed. So I can show you that here in my Spring Boot app, and it's literally one line of code with an SDK. So now this will only work depending on network operators. So I'm going to test it with a virtual CSP, where if I give it an even ending number, it will return true, and an odd one, it'll be false. So if I go back
Just one thing, Sina, I forgot to mention one thing. So a lot of this network APIs require you to register with every single mobile operator, and we manage all that for you. But in order to develop, you don't want to wait for that to happen. So what we did is we created a virtual operator that allows you to test all these different APIs without actually using real numbers. And this is
Yeah.
what that's virtual CSP is. It's something that you have by default. You don't need to do any legal paperwork for that to happen, but it allows you to test things everywhere.
Yeah,
Sorry, I
thank you,
forgot to
Paul.
mention that.
Yeah, that's okay. Thank you for explaining. Yeah, so hopefully that gives you a bit of context. So if I go back here and I put this number, I trigger some code, and it is as simple as you see here is the code. I could even call the other endpoint if I wanted. So if I say check SIM swap, and I put the number here, it's going to give me false. So that means it wasn't swapped, but if it ends in a odd number, it should be true. Okay, maybe it's the other number I have to use. But yeah, if I run through this, you'll see it'll give you back a date here. So that's SIM-swap. You can do it this way. So now if I go to number verification, so number verification is I have it here, is it's a different API. It's rather than checking for kind of the SIM card, this is more about is the number associated with the device. That's what you're essentially wanting to check. So you can do this using the mobile network. So if you follow, essentially checking using the mobile network in a way to do 2FA. And the process is, in terms of the authentication, is also fairly involved. It uses a different OAuth 2 flow with all of this requests and responses and so on. and it's mostly done on the client side because you want to verify a device essentially. So I'm not going to go into all the details of how it works, but you can see that it can be quite involved as a CAMARA standard. And I can show you a demo on, if I just share the presentation, of here we go. Yes, so on the client side, I can show you a demo. So that's kind of the high level overview, if you like, of how it's supposed to work. You can see it's many steps, mostly because of the authentication. So essentially, you make a request, you build a URL, and then you follow that URL on the client device, which then generates an auth code, and then you exchange that auth code for an access token on the server side, and then use that to make the API call. To make that simpler, what we have is we built a product on top of that called Silent Authentication. Now, this is part of our Verify suite, and what it does is it allows you to essentially implement 2FA without having to know all the details about how it works underneath, especially regarding the auth. So it would be using just a JWT, and of course we have SDKs to make that simpler. And I can demo that for you right now. That this kind of is a layer on top of that. So again, you can do 2FA, but without a code. There's no code involved. It's just following a link on your mobile device. So process-wise, it's very similar. But again, for the implementing that is kind of simpler as well, slightly simpler. So here is how it would work on the client side. So this is SMS. This is kind of your traditional 2FA, how it would work. So that's your SMS, and for Silent Auth, again, you've got your phone number, but now notice how there's these redirects happening, and you get authorized. There was no code involved, right? The code exchange happened in the background. So if I just share, I'll show you a live demo of this working on the server side. So if I go back to my application here, now I talked about our APIs and SDKs and how we have various APIs. We have like messaging, for example, and different channels and things you can send. But we have a Verify API as well, which what this allows you to do is, again, 2FA using various channels. You can use email, you can use SMS, voice, WhatsApp, etc. Right? Now with Silent Authentication, again, you put in the number, you can put in the brand, and in order to, because of course this is going to create a link for me to follow, I'm going to do this on, I'm going to use our Messages API to send myself a message. So if I do this, I'm going to get a text. If you can see there's a text I've got, follow this link on mobile data. So I'm going to follow it, and when I follow it, there we go. I've got a breakpoint here, just so you can see what's going on my phone. It says redirecting. This is now the webhook coming in, and there's a code in the background, but this is all happening, right? So I'm going to keep going. I'm going to get a message on my phone. It's successful, and I can validate it. And again, I can see the code that came in. I won't bore you with the details of this, but yeah, so just using the SDK, again, it can be a few lines of code, and it says code match. Now this code, of course, I never entered a code, I never saw a code, but this happened in the background just purely through the sim. So that's kind of silent auth, and number verification.
Can I
Works
just
similarly.
one other thing? So there are two major differences between what we do here for verify and also and the silent auth in verify and SMS in verify is you both don't need the PIN, but also you check that the device that consumes that particular silent auth is actually the device it is. So it adds an extra layer of security on top, which is evident of the first thing you might think is just a easier user experience, but it adds an extra layer of security as well. So obviously it's more work for us as developers, and it adds more stuff for us to do, more story points, if you like. But it leads to a much better user experience for our end users, and that's what we're trying to achieve at Vonage, is make it as simple as possible for the end user to actually consume your products.
Yes, exactly. So that's the main thing, is that what you're verifying is that the device, right? You're not verifying, like, this can only work if you follow the link on the device. So I built a number verification demo as well in like the last hour. And so number verification, I'm going to use a virtual CSP to show you how this works. So again, I'm going to use a number. And I've
Could I
got some
just interrupt? Could I just interrupt one more? Sorry, Sina.
Yeah.
I think also we need to tell people the difference between verify and number verification. So number verification and SIM-swap are network APIs. Verify is a product that we have that builds on top of other products that we have. So the 2FA product that we have builds on top of our SMS product, our voice product, our WhatsApp product, and we added number verification. And number verification inside verify is called silent auth. And it's
Yeah.
just a channel inside verify. That's the relationship between those two products.
Yes, exactly. So it's all about layers of abstraction. So you have your like raw messaging APIs, you have like voice, etc., and then we have this verified product, which kind of uses these other APIs, SMS, voice, number, network, etc., all encapsulated in one product to do 2FA. So if I go back to here, what's going to happen is with number verification, again, you'll see the process working. If I put in a number, and what I'm going to do is it's kind of a two-step process. I build a URL initially, so that's what I'm doing here. So there's my URL, and this is the URL that I'm going to redirect, right? So you see it's got all the parameters here, the OpenID, auth, and etc., and it's asking for a code and so on. So this will be submitted to this URL. So I'm going to run through that, and you see it's going to redirect, and that's what it's doing in the background here. And now I forgot to put a breakpoint here. There we go. I caught it in time. So now it's coming back with this code and so on, right? So it followed the redirect and it came back with the code, and I'm just going to run through it, and it's going to say number matches, right? So that's kind of you can see how the silent auth, it kind of wraps this, but there's a lot of auth that goes on underneath in the SDK for how this is handled. But from an end user's perspective, you can use kind of either one, but implementing the silent auth makes the user's life easier, but functionally it behaves the same way because it's using this API underneath. So that's kind of that. So let me go back to the presentation.
One small additional thing that we need to tell people, because it looks like magic, and it is magic, and people might wonder how it works underneath the cover. And there is a reason why Sina had to go and follow that link on his mobile phone. Is that link actually goes and does a lot of redirects through the network operator that his number belongs to. And all that redirects are happening behind the scene, and eventually you get the code and you complete the process. And because of all those redirects, you'll need to run that URL on your phone, but under the mobile network that you have. So you can't be under wireless on the phone. Hopefully in future versions we'll be able to do that. But in this case, you'll need to be on that particular network. And what that URL does, it creates a direct connection between your mobile phone and your network operator. And in effect, if you think of it, is like a bit like delegating trust to your mobile network, right? That's what we're doing. And the reason we do that is because those are the ones that ultimately give you that phone number and know who you are, and we can delegate trust to them. And that's the reason you have all that process on it. Obviously, there will be edge cases, so we're among friends, so we can say you have edge cases, right? So if a user is on Wi-Fi, you need to signpost it a bit if you do it on the web. With the SDKs we have on iOS and Android for the client side, you don't need that signposting. We have ways to force that particular connection to go through the wireless connection. And by wireless, I mean mobile connection. There are also other edge cases. If, for example, if you use the phone number for voice, but you use an eSIM for data, you might run into some problems. And we're working with the mobile operators and with CAMARA project to close those gaps and make it available everywhere. Another thing to mention is the fact that as more mobile networks come on board, there is limited availability. So at the moment it's just Germany and Spain. And the API on its own, that's why we believe it makes more sense within the verified product, because in the verified product, you have this fallback mechanism. So you can set the first channel as silent off, and if it's not available, it goes to the next one, and the next one can be SMS or voice. So together with other channels, you can start adopting it. You can start putting out there, have enhanced security, take advantage of it. And over time, it's a bit like, all the good products, they become better over time because we're going to onboard more CSPs, you have a better coverage, and then you're going to reap the benefits more from this without necessarily having to update the code. So it's very much a product that we just launched this year. We actually launched it at Mobile World Congress back in February, and we're seeing a lot of adoption, and there's a lot of enthusiasm in the industry for it. So this is why we think that adopting it as soon as possible will make your products better.
Yeah, exactly. Thank you for explaining. So yeah, I think that is just about wraps it up. So yeah, the CAMARA initiative is open source. It's a working group, and there's lots of we just looked at two APIs today, CAMARA standards, and I showed you how you can build APIs on top of that API with our Silent Auth product, the user's number verification. But there's all sorts of things coming. There's like location APIs, should be useful for like smart devices, IoT, things like that. So all of these things are works in progress that take advantage of 5G capabilities. So more APIs coming in the future. So all this programmability built into the network that is accessible to developers. And of course, we'll be building SDKs for these in due course. Now, one final thing we want to announce is a hackathon that we're running. So it's a 1 month long hackathon, so it gives you maximum flexibility to kind of work on it, and it should only take a few hours. And it's an alien themed invasion of like aliens are invading Earth, and we want to make some defense systems. Communication, of course, being vitally important in any kind of crisis or invasion or war. So we invite you to try out our APIs to build things around this. Now, there will be an email around this, so you look out for that, and it's starting in a couple of days. And what's in it for you? Well, we are giving you the chance to win £250 of Amazon voucher and a coupon code for Vonage APIs for €250, which is plenty to use our APIs to build a substantial use case around. So yeah, look out for that, and we look forward to taking any of your questions. Thank you.
Any questions about the network APIs or any other products in general that we have at Vonage? So in the hackathon, you'll be able to use anything from messaging. So we have a traditional SMS, but also we have WhatsApp, we have Viber, we have Facebook Messenger. You'll be able to use voice. So you can do voice to real phone numbers or between your browser. So you can, for example, you can make your browser ring your phone number, your real mobile number. And there are all sorts of APIs like that. We support SIP as well. If you're familiar with SIP in an enterprise environment, we have a video API. In fact, this meetings.vonage.com is built using our video APIs. So it's a product that we build again using our building blocks, and you can see how well it works. And also you can use network APIs. And what's nice about network APIs, you can try them, as I said, with your virtual operators today. You don't have to do anything in particular, and also it doesn't cost you anything to try them because you'll use the virtual operator. So yeah, that's what we had for you today. Hopefully you found it interesting. Happy to answer any questions. I put a link there in the presentation to our community page. You'll find there all the different ways to talk to us. We also have a community Slack that is open to anyone to join, and we have different channels in there with different for different products. And you can go and ask questions, and the best person to answer that question will jump in and do that. And yeah, that's all we had. If there are no other questions, I would like to thank you all for joining us. Hopefully you'll have a good day, and I'll see you around in the hackathon. Excited to see your variation of alien invasion happening between now and mid-November. Thank you, everyone. Have a lovely day.
Thank you.